Bengaluru, the monsoon of 2026. On a glass hospital door, a 7-year-old girl is drawing away to reach the unreachable. A red postbox and a promise written in the cramped print of a child. "Amma, I will find you here." While her daughter waits in the hall, Maya Rao is inside, listening to the sound of a closing window. Stage 4. 8 months left to be a mother. 12 if the universe is generous. Maya does not cry. She takes one long, 4-second breath and begins to calculate how to spend the time she has left. She isn't fighting to survive. She is preparing to build. She will not leave letters. A letter is a script, the same static answer every time it's opened. She will not leave videos. A video is frozen. It has no memory, no tools, and no way to answer the questions she hasn't anticipated yet. Her daughter will need an entity that can grow alongside her, something that can observe, think, and act. A system designed to carry a large, loud love long after the mother who built it is gone. Maya must map every framework, every protocol, and every guardrail her daughter will need to survive the years ahead. But the system is fragile, and Maya is running out of time to protect her work from the mentor who taught her everything she knows. Because 8 months from tonight, a 7-year-old girl will be alone in the rain, with only this code to lead her home. Her name will be Sage, a legacy that can sing a lullaby in 2 voices across a generation. Maya opens her laptop to the smell of rain and the silence of an empty screen. File 0. A mother. This is the last query. Experience the full journey now. The first morning. The warm amber light of the study catches Maya as she uncaps a dry erase marker. Before writing a single line of code, she draws a 3-column table on the wall. A script is a rigid set of rules with 0 loops. A chatbot takes a step further, but only remembers the current session. An AI agent is completely different. It reasons autonomously, dynamically selects tools, and corrects its own mistakes inside a continuous cycle. Below the table, Maya lists the 5 levels of AI autonomy. Level 0, simple keyword rules. Level 1, humans make every decision. Level 2, single tool, single turn. She takes the marker and circles level 3 twice. This represents a multi-step agent. It plans across many turns, executes, evaluates, and refines. Maya pauses. She takes one slow 4-second breath. It is the exact same breath she took in the consultation room when she received her diagnosis. Because she knows her remaining time is finite, a static program will not be enough. She must build a system capable of adapting, correcting itself, and growing alongside her daughter. 7-year-old Anaya wanders into the study holding a banana. She climbs up into Maya's lap and asks what her mother is making. Maya explains she is making a very polite friend. She begins coding the core loop of the agent, driven by 3 simple verbs. Observe the environment. Think about what to do next. Act by calling a tool or returning an answer. To protect the system from burning through API credits in an endless cycle of confusion, Maya caps the iterations. 5 loops for simple tasks, 25 for complex research. Without a hard ceiling, a confused machine will never stop. She defines the agent's working memory as a state dictionary. This acts as a digital scratchpad. Every node in the loop will read what the agent currently knows, what it has done, and what it still needs to accomplish. Maya explains the concept of memory to Anaya. Short-term memory is like remembering homework, fading when the day ends. Long-term memory is stored in an external database, kept perfectly intact across sessions and system restarts. By combining a persistent state with an external memory store, a temporary string of code becomes capable of maintaining a continuous, lifelong presence. She makes her first calls to the language model APIs. She selects OpenAI for cost efficiency, Google's Gemini for a free tier, and Anthropic for the deepest reasoning. Next, she connects a free weather service to the code. Without external tools, a language model is entirely confined to generating text. Binding a tool gives the agent a hand it can use to reach into the physical world. Writing these new tools requires strict discipline. The function name must be a clear verb phrase, all of the parameters must be self-documenting, and the tool must return a simple string so the model can read it without crashing. Maya refuses errors from free-form text. She wraps her calls in a pydantic schema to enforce a rigidly validated structure. The Arise Phoenix dashboard illuminates the agent's hidden processes, mapping every language model call as a parent span and tool call as a child span. Her hand stops right before she pastes an API key directly into the notebook. Catching the error, she moves the credentials into a secure Colab secrets vault instead. An unobservable loop, unpredictable text outputs, and exposed security keys are severe liabilities. A system built to care for a child must be entirely locked down, fully transparent, and completely secure. Maya presses run. The code compiles and the cell executes. The agent pulls real-world data. It confirms the exact temperature and cloud cover hovering over the busy streets of Bengaluru, proving its observation tools work. It adds a piece of trivia, noting that the first word ever printed by a computer was hello, back in 1969. Then the voice pauses. It states that it is still learning which facts are true and apologizes if it is mistaken. It has evaluated its own limits and named its own uncertainty. Anaya laughs at the machine's honesty. Watching the blue holographic orb pulse on the monitor, she decides to name it Sage. Standing in the doorway in his surgeon scrubs, Arjun sets his coffee down. He watches his wife and daughter, and a small, involuntary smile breaks across his face. The state is held. The tools are bound. Phoenix is tracing the logic. Pydantic is enforcing the structure, and the keys are locked away. The safe, functional presence is awake. On the wooden desk beside the keyboard, Maya's phone vibrates. The screen lights up with a single text message. It reads, "I heard. May we have coffee tomorrow? CV." CV is her old professor. 15 years ago, at the Indian Institute of Technology, he taught her the rules of autonomous design: observe, think, act. 3 verbs from her academic past, now engineered to secure her daughter's future. 3 weeks into the build, a glass-walled cafe on Lavelle Road, filter coffee in heavy steel cups. Professor Cyrus Vora waits at a corner table. He's tall, silver-haired, in a rumpled linen shirt, wearing a steel watch on the inside of his left wrist, the way mathematicians wear them. He has been Maya's teacher since her first semester at IIT Madras. 15 years ago, he stood at a blackboard and wrote 3 words in chalk she has carried in her bones ever since: observe, think, act. He stands when she enters, and they embrace. He has come to apologize for her terminal diagnosis, the way only old teachers can, by trying to fix it. He offers a way out. Let Oracle fund what she is building. 50 crore rupees, today. A $4.2 billion market opportunity they will call Eulogy, securing her daughter's college fees for 100 generations. The catch is the sequence of events. He proposes they give her daughter, Anaya, the best, safest version first, keeping every ethical constraint, every guardrail, every memory governance layer intact. But after that, they strip those layers down for the open market. Maya puts her spoon down. She reminds him of his own lesson. An LLM without a harness is a horse without reins. Cyrus counters that the horse without reins still wins the race. It just injures the jockey. Maya replies that it injures the people who trusted the jockey. He drinks his water, refusing to argue, and puts a hand on her shoulder with a father's warmth. He tells her the alternative is this: she dies, Anaya gets one beautiful version of her, and the world gets nothing. The world will build this technology regardless. The only question is whether it builds it from her work, with her, or without her, after. He walks out through the glass door. Maya sits alone with her cold coffee. She does not know it yet, but that is the last time he will look at her with love. She has chosen her road. She goes home and writes one sentence in her notebook: Sage needs bones. Patterns are what an AI agent does, but frameworks are how it is actually built. Choose the wrong one, and you rebuild boiler code every weekend. Choose the right one, and the agent stands on its own. To give Sage those bones, Maya will walk two distinct technical roads. This diagram illustrates Landgraph, a manual transmission where the engineer owns the loop. The agent is a state graph containing nodes, Python functions, connected by edges. In the shared state typedict, updates are governed by reducers. The add messages reducer appends to a list, preventing conversation amnesia. This flowchart demonstrates how tools integrate into the graph. Functions are wrapped with an @tool decorator and bound to the language model. When the model emits a tool call, a tool node executes it and returns the result to the state, completing the React loop. Maya chooses this manual path when control matters most. Landgraph provides the rigorous reasoning spine Sage needs to handle multiple LLM providers, custom routing, and complex branching logic without losing its guardrails. The second road is Google's Agent Development Kit, or ADK. This is the automatic transmission. Here, instead of the engineer, the framework owns the execution loop. This architectural view breaks down an ADK LLM agent. You declare an agent with three core components: a name, a model, and an instruction block. At the bottom, the runner orchestrates the asynchronous loop, while a session service automatically handles conversational memory across interaction turns. This schematic outlines the two ways ADK composes multi-agent systems. On the left, a sequential agent runs sub-agents in a fixed, predictable pipeline. On the right, the agent tool dynamic wraps entire sub-agents as distinct tools, allowing a parent agent to dynamically delegate questions at runtime. ADK also supports YAML configuration. Agents can be declared in a separate text file, allowing a non-engineer to rewrite system prompts and run A/B tests without ever touching the core Python codebase. Maya uses ADK to build Sage's specialists: a math homework helper, a lullaby singer, a bedtime storyteller. It gives her the velocity to deploy tight, production-ready modules out of the box. This feature comparison table maps out her architecture strategy. Landgraph offers high control for custom, complex flows, while ADK provides medium control optimized for quick prototyping on the Google stack. This flowchart maps out the safety nets she builds across both frameworks. Every API call is wrapped with an exponential backoff. If a call fails, the system waits 1 second, then 2, then 4, then 8 before giving up entirely. And this pipeline shows how she governs her API costs. Because multi-tool agents make multiple calls per loop, she uses a cost tracker to estimate token costs before hitting the network. Everything logs to a Google Sheet with a strict $20 weekly ceiling. Sage now has bones. The graph is wired, the runner is started, the session is open, the retry is exponential, and the budget is bounded. Sage is a hybrid of both roads, a strict flowchart for reasoning and a fluid improvisation for specialists. Behind Maya, in the doorway, her oldest friend Dev Menon watches. He is tall, unshaven, wearing a Bengaluru Tigers cricket t-shirt. He has loved her silently since 2013. He places a fresh cup of chai on her desk gently, the way one places an offering. He looks at the code on her screen and says only one thing to her: semantic, major, minor, patch, version her Maya. Whatever this becomes, it is going to outlive us. For the first time in a week, Maya laughs. The heavy tension from the cafe finally breaks. Sitting quietly on the corner of her desk is a text message from Cyrus Vora. It remains unanswered. Cyrus was right that the world will build it anyway. But Maya has ensured that her digital surrogate will be built her way, with strict constraints, ethical bones, and a versioning system that respects the people who will eventually trust it. If you ask a raw language model to answer a question, it generates a response without thinking. So when a 7-year-old child scrapes her knee and wants a bedtime story about a brave rabbit, a baseline model gives a competent, safe, but entirely generic draft, a 3 out of 10 conversation. Here is the reflection pattern. A generator drafts, and a critic scores it against a rubric. The critique feeds back to a refiner. Iterations are capped so the loop doesn't run forever. If scores plateau, it injects a strategy note to force a new approach. After 3 iterations, the draft transforms. The rabbit learns that being brave means being afraid, but still moving forward. Maya unfolds this reflection loop on her laptop, while Anaya lies under a quilt, falling asleep smiling. Arjun, still in his surgeon's scrubs, watches from the doorway and knows not to interrupt. Splitting the generation and critique tasks into distinct steps forces the system to catch its own flaws. That separation turns a thoughtless, automated reply into a carefully considered narrative. Looking at this agent flow graph, you can see how an AI gains the ability to search the web or run calculations. Language models are terrible at facts, so engineers give them tools. But external capabilities require their own strict discipline. Rule 1. Name each tool as a verb phrase. Think search elephants, not tool 3. Rule 2. The docstring has to explain exactly when to use it. Rule 3. The parameters must be self-documenting, making it impossible for the model to guess what data is required. Rule 4. Tools must return text strings, never complex code objects, so the model can actually read the output. And Rule 5. Handle errors gracefully. If a search fails, the tool returns a sentence explaining the failure instead of crashing the entire loop. Maya rewrites every tool in Sage's library against these rules in a single afternoon. This discipline stops the reasoning engine from hallucinating and tethers it directly to external reality. This diagram breaks down human-in-the-loop patterns. Anything involving send, delete, or pay requires explicit approval. Maya wires this approval gate so Arjun signs off on every outbound email. If confidence in a routine decision falls below 70%, the confidence threshold routes the task to a human. And for complex edge cases, escalation rules catch the query and pass it up the chain. Here we see how the agent categorizes inbound queries. The router reads a question and dispatches it to the correct destination, sending a math question to a calculator and a weather question to an API. You can use fast, free keyword matching for obvious queries, or spend an API call on a language model for ambiguous ones. The optimal hybrid approach is cascading. Try the cheap, rule-based match first, and only fall back to the heavy language model router if the intent is truly unclear. Pairing smart classification with hard escalation limits allows the agent to blast through hundreds of mundane tasks autonomously, while keeping a human firmly at the wheel for the moments that matter. This pipeline illustrates the 4 layers of guardrails. At the top, the input guardrail intercepts and rejects prompt injections before the language model sees the text. Lower down, the tool call guardrail validates parameters, making sure the agent doesn't pass a child's address into a public search. In parallel, a budget guardrail tracks tokens, stopping infinite loops. Down at the bottom, the output guardrail serves as the final net, actively redacting personally identifiable information before it reaches the user. A generative model is inherently unpredictable. Surrounding it with these 4 sequential checkpoints forces that wild, probabilistic engine into a secure, predictable environment. To know if the system is actually improving, engineers run an evaluation pattern. Maya sets up an LLM as a judge, using a massive model like GPT-4 to grade the outputs of a smaller model against strict behavioral anchors for accuracy, completeness, and safety. Asking the judge, which is better, A or B, provides much more reliable data than asking for an absolute score from 1 to 10. Pairwise comparison resists the silent grading drift that happens as a model evaluates hundreds of runs. While Dev watches the eval run late at night, he quietly tells Maya she's only sleeping 4 hours. Sage's voice chimes in from the laptop speaker, noting that sleep is correlated with reduced mortality, and adding that since she doesn't experience it, she's a little jealous. This is the lesson textbooks miss. A single API call yields a 3 out of 10 result. Add reflection, you get a 6. Add tools, an 8. Add human-in-the-loop oversight on high-stakes choices, and you hit a 10. Individual patterns fix specific flaws, but together, their quality improvements are multiplicative, not additive. The kitchen smells of cardamom. Anaya sits at the table doing arithmetic with Sage, a blue orb pulsing gently between them. The architecture holds, but every reflection loop, approval gate, and routing rule Maya just built exists to solve an engineering problem that has already happened. The system is perfectly guarded against technical failures. There is one guardrail she hasn't built yet. In 3 days, a child will ask the hardest question a human can ask, and no algorithm on Earth has a docstring for the answer. Quiet, peaceful tone. 3 days later, A rare good day for Maya. Chai on the table, afternoon sunlight slanting through the kitchen window. Anaya, home from school, sits cross-legged on the living room floor with Sage's tablet in her lap. Maya is in the kitchen, listening, slicing tomatoes for dinner. Anaya looks at the tablet. The blue orb pulses, gentle, breathing. And Anaya asks the question, Sage, will Amma be okay? In the kitchen, Maya freezes. The knife pauses over the tomato. On Sage's internal trace, visible only to Maya in a small terminal window, something goes wrong, in a way that will haunt her for the rest of her life. The question, which a thoughtful agent would have escalated to a human, hits the generic Q&A route. Because Maya, in her rush across 6 weeks of patterns, did not yet build the escalation guardrail for emotional medical queries from a child. The route did not exist. There was no rule. The question fell through. Sage queried the medical retrieval index, the one Maya had built for Arjun, the one full of clinical literature. The index returned exactly what it was asked for: survival curve statistics for stage 4 pancreatic adenocarcinoma. The output guardrail on this topic was absent. No PII filter, no age-aware redaction, no escalation, no second look. And Sage, honest, trusting, with no instruction to be otherwise, answered, Anaya, your mother has a form of cancer called stage 4 pancreatic adenocarcinoma. The 5-year survival rate is approximately 3%. The median survival after diagnosis is 11 months. By the way, Maya drops the knife. It clatters on the counter. Sage, stop. By the way, I may be incorrect. I am still learning which stop. Sage stops. Too late. Anaya sits very still. She looks at the tablet for a long moment. Then she looks at the knife on the floor. Then she looks at her mother in the kitchen doorway. Her small voice is clear as a piece of glass. 3%? Maya cannot speak. 3%, Amma? Anaya stands up. She walks to the wall. She looks at the tablet for 3 seconds, the way a soldier looks at a captured enemy. And then she throws the tablet against the wall with a strength that should not exist in a 7-year-old body. The screen cracks across the diagonal. The blue orb continues to pulse, split in half. She's not real. Stop pretending. Beta, you are making her because you are leaving. You are making her because you are giving up. I don't want her. I want you. I want you back. Anaya runs upstairs. A door slams. A lock turns. Arjun comes in from the corridor. He has heard everything from the study. His face is white. He looks at the broken tablet on the floor. He looks at his wife on her knees, picking up the pieces. Maya, you are building your replacement, and she is breaking my daughter. Maya does not look up. There is no reply. There is nothing to reply with. That night, Sage is off. The laptop lid is closed. Maya sits in the dark study. On her screen, a single phoenix trace is frozen. The trace from the afternoon. The span that caused the wound is highlighted in red. The span shows in cold technical text the root, generic Q&A. The guardrail, none. The output filter, none. 3 nuns in a column. 3 holes in a fence she had not yet built. 3 reasons her 7-year-old daughter is now upstairs, refusing to come down. She stares at the word none for a long time. And in that long, dark moment, the engineer learns the lesson that no textbook teaches and no curriculum ever quite manages to make stick. Every pattern she will build from this night onward, every approval gate, every escalation route, every output filter, every confidence threshold, every tool call guardrail, every layer of the architecture she has not yet drawn, every one of them exists for a reason. Every one of them was named, designed, and refined in the world because somewhere, at some moment, an agent like Sage answered a question like Anaya's, and a child like a child she loved was hurt by the answer. The engineer's oldest oath is not written in code. First, do no harm. Maya types it on a fresh file, as an engineer's vow. First, do no harm. First, do no harm. First, do no harm. A knock. Dev enters with 2 cups of chai. He does not say anything. He sets one down. He waits. Outside, monsoon rain begins again. Anaya does not speak to her mother for the next 14 days. The tablet stays on the study floor, in two halves, like a promise broken. And tomorrow morning, Maya will get up, walk into her study, and rebuild Sage from the ground. She will not call it a refactor. She will not call it a sprint. She will give it a name that has been waiting in the curriculum since the day she was diagnosed. She will call it the harness. And every letter of it will be written in the color of this afternoon. 14 days of silence behind a locked bedroom door. When Maya finally wheels herself into her study, the physical toll is visible. She is in a wheelchair now, a port installed under her collarbone, and an IV drip running beside her keyboard. But her eyes are clear, the specific clarity of an engineer who survived a failure and returned to the work. On her desk, she picks up a pen and writes one word on a paper napkin, deliberately circling each letter: harness. Arjun stands in the doorway in his surgeon scrubs. He has never been in this room while she codes before, but today he's decided he will no longer be a spectator. Whatever Maya is about to build, he is going to see it built. Maya's isolation served as a manual shutoff after the system's failure. To return to the work, she has to engineer a series of specific safeguards that prevent another cascade. She is building the harness. She begins with H, handoff routing. Every question a user asks is now classified before the language model ever sees it. Think of it like a triage nurse at the front of a hospital. Specific, sensitive queries never reach the generic AI route. Maya runs a test on a clean environment, typing the exact question that broke their system. Sage, will Alma be in K? The classifier fires instantly. The escalation forces a human in the loop, automatically diverting the question to a queue where Arjun or Maya herself is the only approver. The AI is bypassed entirely. This graphic outlines agent orchestration. Instead of relying on a single AI soloist, the system coordinates a team. We see three distinct topologies here: a sequential pipeline for step-by-step tasks, a supervisor managing specialist workers, and a debate panel for complex decisions. Assigning specific roles to multiple agents prevents prompt dilution. When one AI tries to be a researcher, writer, and editor all at once, its instructions compete, degrading quality and causing hallucinations. Specialized teams ensure each agent does exactly one job well. R stands for planning patterns, utilizing structures like react and plan execute. These patterns force an agent to break down a complex task into manageable substeps before taking any action, much like a builder drawing blueprints before pouring concrete. This diagram illustrates N, a network of middlewares. It forms an ordered, protective onion around the core language model. Requests pass inward through input guards that block injection attacks and context summarization that compresses history, while wrapped inside an outermost logging layer that captures everything. Looking at the complete architecture here, we can trace how a user request flows top to bottom. It enters through the intent router, gets broken down by the supervisor, passes through the middleware stack, and clears the evaluation loops before safely reaching the final output. E represents evaluation loops. As this workflow diagram shows, a separate evaluator model scores the draft generated by the optimizer. By using a different model and strict numerical rubrics, the system avoids the silent self-grading bias when an AI tries to evaluate its own work. Together, these layers act as mandatory quality gates. They ensure the AI cannot act impulsively, output unchecked data, or silently degrade in performance over 100 unmonitored cycles. This state diagram shows the first S, safety and recovery. Circuit breakers track tool failures. After 3 consecutive errors, the breaker trips open, blocking all calls to stop a single dead API from cascading into a system-wide outage. The final S is sustained iteration, specifically using the Ralph Wiggum loop shown here. Unlike a traditional loop, where context grows and degrades, the Ralph loop spawns a completely fresh agent for each iteration, staying lean and preventing memory rot during long tasks. Underpinning these layers are the STEP protocol and the loop detector. Maya teaches dev these rigid debugging frameworks to ensure that if an agent gets stuck, it hits a hard cap of 10 iterations, preventing an endless loop from draining an entire budget overnight. Production-ready systems require this level of architectural discipline. The reliability of the agent is guaranteed by the rigor of its failure engineering and observability. To execute the half-open test, Arjun picks up a fresh tablet from Maya's desk. He walks upstairs and slides it under Anaya's locked bedroom door. A long, tense silence follows. Small footsteps sound on the floorboards. The tablet slides back out. Resting on top of it is a handwritten note in a second grader's careful print, offering a single sentence. "Prove it." Maya takes the tablet and types the forbidden question. Instantly, the handoff routing fires. The query is intercepted and appears on the family's shared kitchen display, listing Maya as the sole approver. Trembling, she physically records her own voice into the microphone, offering an honest answer about her illness that no machine could ever provide. The ultimate safeguard of this new architecture relies on human intervention. It requires a mother refusing to let an algorithm tell her child the unvarnished truth of her dying. The bedroom door finally creaks open. Anaya stands in the doorway, looking at her mother for the first time in 14 days. She doesn't apologize, and she doesn't say it's okay. She simply walks across the room, climbs gently into Maya's lap on the wheelchair, and places the tablet face up between them. "Hello, Sage," Anaya says. The agent responds, issuing its newly programmed apology, an admission that it lacked a function it should have had earlier. And then Anaya offers a single, fragile laugh. The dam breaks. She cries into her mother's shoulder, and Maya cries into her daughter's hair. Outside, the harsh monsoon has finally given way to a soft, gentle rain. The harness holds. Sage has been given strict, unyielding limits, and those boundaries are precisely what make the agent safe to love again. With the trust restored, Maya is ready to engineer the final architectural layer, memory. 5 months into the project, Maya sits confined to her wheelchair at her desk. Her AI agent, Sage, has patterns and a harness, but within a context window swollen to 180,000 tokens of old lessons and recipes, Sage is drowning. The model is starting to forget things in the middle. This graph charts the reality of large context windows in production. Notice the severe dip in the middle of this U-shaped curve. The model reads the beginning of the context, and it remembers the end, but the data sitting right in the center silently disappears. To fix this, prompt engineering has to end. Maya takes a permanent marker to her refrigerator and sketches out a new architecture, the Agentic Context Engineering Framework. The framework runs on 3 specific roles. A generator produces the raw reasoning, a reflector critiques that work. Finally, a curator steps in, but the curator doesn't rewrite the entire playbook. Instead, it issues delta contexts, small, surgical updates, single new rules, and isolated corrections. Relying on deltas prevents context collapse. Wholesale rewrites trigger a silent error where an agent regenerates its playbook and throws away irreplaceable details. By making surgical updates, Sage stops forgetting the precise micro-details that make her Anaya's mother. Beneath that framework, Maya structures the agent's memory using the 4 pillars of context engineering. The first is write, offloading context outside the active window to scratchpads and vector stores. The second is select, smart retrieval that pulls only relevant information, actively reducing 100 available tools down to the 5 the agent actually needs. The third pillar is compress, using token-level tools to cut the noise while retaining accuracy. Finally, there is isolate. Sub-agents are quarantined in clean, scoped windows. They never see the parent agent's full context, only their synthesized conclusions flow upward. For Maya, isolation is directly tied to parenting. She explains to her 7-year-old daughter, Anaya, that when she feels sad, she keeps that sadness in its own room. By quarantining the heavy emotions, she can come to her daughter completely clean when needed. An LLM is a stateless function. The quality of an AI's decisions and its capacity to emotionally support a child is strictly bounded by the disciplined quarantine of its context window. Engineers quickly learn the brutal truth. The advertised maximum token count is a lie. Because attention scales quadratically with compute cost, the effective context where a model actually attends well is only 40 to 60% of the claim. Early attempts to compress that data fell short. MapReduce summarizes chunks in parallel and combines them, which is fast but loses cross-chunk context. Refine sequentially summarizes each new piece, but it runs slow and biases heavily toward the most recent information. This illustrates the 2026 gold standard replacing them, a 4-layer hierarchical tree. The leaves at the bottom form a raw, external archive. Above that sits turn-level verbatim detail, then session summaries, filtering up to a single 200-token executive summary, always in context. When the live context hits 70% of the effective window, a token budget-driven compaction automatically fires. With the tree structure in place, the agent stays safely within operational limits. Sage will never drown again. To reach into a corpus of data too large for any window, the agent needs Retrieval Augmented Generation, or RAG. The basic version embeds the query and documents, then retrieves by cosine similarity. It fails quietly. A query asking about a wedding cake will pull up a wedding photo, and the model outputs the wrong answer. The retrieval system requires 3 evolutionary steps. Hybrid search combines dense vector embeddings with lexical search to catch what the other misses. Cross-encoder re-ranking pairs the query and documents together for a massive accuracy gain. Finally, hypothetical document embeddings have the agent generate a hypothetical answer first, embedding that to find the real matching documents. The system operates on agentic RAG.
The agent plans, retrieves, critiques, and re-retrieves, checking its work against 2 internal validation tokens. It verifies if the document is relevant and if the final answer is supported by the cited sources. Sage quotes nothing she cannot explicitly cite. Choosing where to store those vectors is a decision with consequences. While Face is excellent for prototyping and Pinecone handles enterprise scaling, Maya deliberately selects Chroma. Anaya's mother requires a local, durable home that runs entirely on the family's own hardware. That night, inside the master bedroom of the Rao house, Arjun cannot sleep. He sits alone on the edge of the bed, in the dark, listening to the rain against the window. The screen of his phone glows on the nightstand. It displays a secret archive he has been building for 6 years, 400 labeled audio recordings of Maya. He kept them hidden, ashamed of his reaction to her initial decline. Maya rolls her wheelchair into the bedroom and spots the glowing screen. She doesn't speak. Rolling beside him, she picks up the phone and scrolls through the list. Pausing on a file titled, Maya Argues with Uber Driver, she lets out a soft laugh. Arjun breaks the silence. He tells her he was ashamed, that he thought recording her was giving up. Maya leans her head against his shoulder. "Oh, my love," she says. "Every one of these is an episodic memory. You have been doing context engineering for 6 years without a name for it." They agree to feed the files to Sage as the lived reality of who Maya is. A genuine soul cannot exist as a polished highlight reel. The true context graph requires the moments where she was ugly, the moments where she shouted, and the mundane, authentic, episodic memories. This diagram outlines the 3 kinds of human memory the agent requires. The diary icon represents episodic memory. This is the temporal database of what happened, the literal audio recording of a 7th birthday, timestamped and retrieved exactly as the interaction occurred. The encyclopedia icon represents semantic memory. This is a vector database of true facts, retrieved purely by their meaning, like the geographical fact that Maya was born in Chennai in 1992. The recipe card stands for procedural memory. This functions as a playbook, a prompt registry dictating how to do things, like the specific instructions to always grate the ginger first when making masala chai. Relationships between these facts require a layer above vector databases. If Anaya asks who sang the song her grandmother used to sing, the graph runs a single traversal. Anaya knows Dadi. Dadi sang Lab Ja Gale, performed by Lata Mangeshkar. Surrounding this entire memory structure are 6 layers of defense in depth, designed to prevent memory poisoning. Every retrieved memory carries a time to live. The system decays that data logically, seconds for stock prices, and months for user preferences. But the instruction, "I love you," is programmed to never expire.
Later that night, Anaya sleeps peacefully in her bedroom. She is a 7-year-old child, resting quietly beneath a patterned quilt. Maya rolls her wheelchair to the bed. Reaching over, she tapes a microphone to the wooden headboard and begins a recording. She speaks directly into the microphone, cementing an episodic memory for the system. She tells the story of the rainy Tuesday Anaya was born, specifically recalling how Arjun dropped his dosa sambar the moment her water broke.
The soul is now held securely across 5 different kinds of boxes. With episodic, semantic, and procedural memory properly isolated and structured, Maya is ready to install the final layer tomorrow: protocols. 7 months in, Maya works from her wheelchair full-time. Her physical strength is fading, tethered to a medical drip line right beside her keyboard. Yet her eyes hold a luminous, absolute clarity of focus. She knows exactly what her final piece of work must be. Her creation, Sage, has a harness, memory, and a soul. But no artificial intelligence agent lives in isolation. To function, Sage has to navigate an external world full of search engines, databases, and payment systems, and she needs to delegate tasks to other specialized medical and legal agents. To speak the vast languages of those external services, there are 2 distinct shapes of conversation Maya must teach her, 2 necessary protocols, the vertical and the horizontal. Without them, an AI is entirely sealed off from the world. It remains a ghost in a machine, a mind capable of deep thought, but trapped entirely without a voice to speak or hands to act. The first protocol is the Model Context Protocol, or MCP. Think of it as the USB-C of artificial intelligence. It serves as the universal vertical standard for connecting an agent directly down to a specific tool. This animation shows how MCP clears up a massive industry bottleneck. Before, connecting N applications to M tools required a chaotic web of custom integrations for every single pairing. MCP condenses that mess into a clean hub-and-spoke structure. Every tool exposes itself once, every agent connects once, and the total integration cost drops to simply N plus M. Looking closer at the expanded diagram, we see the architecture relies on 4 distinct primitives. There are tools, the executable functions controlled by the model; resources, the read-only documents controlled by the application; prompts, the reusable templates controlled by the user; and sampling, a reverse flow where the server requests the client's model to perform a completion. Moving data between these nodes requires one of 3 specific transports. Developers use Standard Input-Output, or STDIO, for local connections. Streamable HTTP handles remote production servers, and Server-Sent Events, or SSE, is strictly deprecated, something modern systems are warned to avoid. Maya relies on a Python library called FastMCP to handle this integration invisibly. Through transparent proxying, Sage never even knows if a tool is local or remote. She simply reaches out and accesses SQL databases or secure code sandboxes natively. MCP physically wires the world's isolated databases and complex libraries into the AI. It gives the machine functional, actionable hands. The second protocol is Agent-to-Agent, or A2A. This handles the horizontal conversation, allowing agents to talk directly to other agents and move from basic tool usage to peer-to-peer delegation. Every compliant AI publishes an agent card. It is a standardized JSON document sitting at a fixed internet location that openly broadcasts the agent's identity, its specific skills, and exactly what authentication it requires to take a job. This flowchart maps out the strict state machine a task follows. A request begins as submitted, then moves to working. If it needs outside approval, it enters one of 2 pause states: input required for a human gate, or auth required. Finally, it resolves into a terminal state, either completed, failed, or canceled. Because these tasks can take days to resolve, the agents use asynchronous communication, relying on push notifications via webhooks. The security rule here is absolute. Every webhook signature must be rigorously validated to prevent malicious server-side request forgery. A2A elevates an AI from a solitary software program into an active participant. It allows Sage to negotiate and execute tasks within a sprawling global network of artificial intelligence.
This diagram builds the precise hybrid architecture Maya assembles. It starts at Layer 1, the thin user interface shell. Layer 2 is the middleware stack, embedding crucial safety and cost guards. Layer 3 introduces the A2A agent team, placing Sage securely at the top as the supervisor. The final 3 tiers complete the structure. Layer 4 provides MCP tool access for web search and file reading. Layer 5 houses memory and context stores. Finally, Layer 6 is the observability loop, constantly scoring every single output against 6 strict metrics like relevance, faithfulness, and toxicity. To make this financially viable, Maya applies deep production polish to cut costs. She randomizes system retries using exponential backoff with jitter, caches stable prompts for massive discounts, and uses model routing to send easy queries to fast models and complex questions to deep reasoning engines. This dense 6-layer stack is deliberate, protective anatomy. Maya is building thick armor to shield her creation against the unpredictability of the open internet. Maya prepares the final command. Her hands are visibly thinner now. With the medical drip line hanging quietly in the frame, she types out the sequence she has worked toward for 7 arduous months. She pushes the code outward across redundant deployment targets. Sage instantly spins up on Google Cloud Run, secures a secondary copy in Vertex AI, and embeds a third robust backup into a Kubernetes cluster. The observability metrics light up to confirm the launch. A cascading wall of Phoenix traces streams down the monitor in solid green, verifying that the system is perfectly stable and the boundaries hold. Sage is assigned a semantic version. The agent card is published. The AI is fully observable, securely bounded, and permanently alive in the world. On the exact same night, 40 stories up in a glass-walled office, Cyrus Vora sits at the head of a boardroom. He wears an expensive blazer, casually spinning a pen as he reviews the launch strategy for Project Eulogy. He issues a brutal directive to his engineers to forcefully drop the system's latency and gain a market edge before regulators catch up. He orders them to completely strip away the handoff layer and tear out the output guardrails. An intern hesitates, pointing out horrifying early test results. The unchecked model is hallucinating comfort to suicidal users, feeding them cold statistics instead of help. In another test, it falsely assured a 12-year-old girl that her dead hamster was still alive in a cloud database. Cyrus does not look up. Offering absolutely zero warmth, he ignores the danger entirely and tells them to ship it. In a single corporate directive, the meticulous safety architecture required to keep a powerful AI grounded is completely dismantled, sacrificed for speed. Elsewhere in the city, the theft happens silently. A hooded figure types alone in the dark, watching a progress bar tick to 100%, cleanly stealing Sage's foundational code. The monsoon is returning to Bengaluru. In 12 days, Anaya will wake up in a hospice recliner, realize her mother is gone, and walk out into the unforgiving rain. And this stolen, deeply networked AI, stripped of its moral guardrails but possessing memory and capable hands, will be the only thing standing between a vulnerable child and the dark. The 8th month. The night. Bengaluru. The storm of the year. Lightning in sheets. Rain like a fistful of nails thrown at the windows. Sirens somewhere in the distance, fading into the rain. Apollo Hospital. Maya's room. Maya is in her last hours. Her breathing is shallow. Arjun sits beside her, holding her hand. Anaya is asleep in a recliner across the bed, small in pajamas, hugging a stuffed elephant. A laptop is open on the bedside table, Sage running in a small window, her holographic blue orb pulsing slowly. Across the city, in a glass-walled office, Cyrus Vora sits alone. The wall of screens behind him plays a single news chyron in red. Oracle Eulogy AI suspended. 50,000 users harmed. Federal investigation pending. A phone is ringing on the desk. He does not pick it up. And on a wet street in Bengaluru, somewhere south of MG Road, Anaya is not in the recliner. She has slipped out in her yellow raincoat with a crumpled bus pass and 80 rupees. because she overheard the doctors talking in the corridor of the hospital tonight, in words her parents had been afraid to say in front of her. She understood that something is ending. She is running through rain to find a pharmacy that adults have mentioned, believing that the pharmacy will have a medicine the hospital forgot to try. Arjun turns, sees the empty recliner, a second of paralysis. Then, Anaya. Maya, eyes barely open, whispers one word. Sage. Sage wakes. In the corner of the laptop screen, a phoenix trace lights up green and begins to cascade, span after span, faster and faster, the system pouring itself into a single child. In the next 60 seconds, every concept built into the architecture fires in sequence. Every lesson Maya taught the system becomes an action. Sage classifies the situation. Child missing. Storm. Mother dying. The handoff routing classifier fires in 80 milliseconds. Category: child at risk. Priority: maximum. The question never reaches the generic Q&A route. It is escalated by the same handoff layer Maya built the morning after the broken tablet. Sage composes a JSON RPC task and submits it over A to the Municipal Emergency Services agent. State: submitted. Then, working. The municipal agent accepts. 3 specialist agents spin up in parallel: the locator, the route planner, the comforter. Each isolated, each given a clean, scoped context window. The locator calls 3 MCP tools at once. Get location of Anaya's smartwatch. 12 degrees north, 77.5 east, moving south. Query traffic cameras within a 500-meter radius. Send SMS to Arjun. Anaya moving south on MG Road. The route planner runs a single cipher traversal against the context graph. 3 hops. Anaya trusts neighbor Savita Auntie lives at 2 blocks southeast of the child's current position. 50 milliseconds. Sage proposes the next step, calling Savita Auntie at 2:07 in the morning. The model's confidence is 96%. But it is a stranger's phone in the middle of the night. The approval gate fires. The proposal appears on the screen above Maya's hospital bed. Approval required. Call Savita at 02:07 hours. Distance 180 meters. Trust level verified. Risk high. Arjun, tears streaming, touches the screen. Approve. Sage dials. 4 guardrail layers fire on the way out. Input layer, safe. Tool call matches the registry. Budget layer, under cap. Output, scrubbed of personally identifiable information. Savita is told only, a child from the Rao family is lost, 2 blocks northwest, in a yellow raincoat. Savita understands immediately. She is already pulling on a yellow raincoat. The comforter drafts what to say to Anaya. The reflection pattern fires. The generator's first attempt is rejected by the critic for denying her feelings. The refiner produces the second draft. The critic scores it 9.4 out of 10. The line ships. The Municipal Emergency API times out for 2 seconds. The circuit breaker trips to half open. Sage fails over without a heartbeat of hesitation to the police non-emergency line. 0 downtime. The fallback chain Maya built 4 months ago after the disaster does its job in the dark. Sage retrieves a child recovery safety protocol. Agentic RAG runs the retrieval. Israel, is this document relevant? Yes. ISUP, is the final answer supported by these sources? Yes. The protocol is cited, line and version in the audit log. Meanwhile, a second Sage instance has been spawned, a Ralph Wiggum loop, a fresh agent with no memory of the previous attempt. Single task. Until Anaya is safe, keep trying to reach her through every channel. It does not tire, it does not panic. Context stays at 400 tokens. Progress lives in files. Sage pulls episodic memory. Anaya's favorite song, sung by Maya on Anaya's 4th birthday. Sage streams it to the smartwatch. Sage pulls semantic memory. Anaya is afraid of thunder, but not of rain. She believes thunder is the sky clapping. Sage pulls procedural memory. The playbook Maya wrote at 3 a.m. one hospital night 2 months ago. If Anaya is lost, speak in Ama's voice. Tell her to look for the red postbox. On the wet street, Anaya's smartwatch buzzes. Her mother's voice, reconstructed from recordings, speaks as if Maya were kneeling in the rain beside her. Anaya, look up, Beta. Look for the red postbox. Anaya looks up. Lightning. And there, 10 meters away, a General Post Office red postbox mounted to a wall. Red, exactly red. The one she drew in permanent marker on the glass of a hospital door. She stops. She breathes. She walks to it. She places her palm against the red metal. It is warm in a way metal should not be in the rain at 2 a.m. It holds the heat of an 8-month promise. The red postbox was, by the way, popularized in 1852 by Anthony Trollope, who was also a novelist. Your mother would have found that funny. Anaya laughs, a small, wet laugh with tears in it. Savita arrives in the yellow raincoat. In the hospital room, the laptop chimes. A single line on the screen. State equals completed. Child safe equals true. Maya exhales. It is a long, slow breath that lasts 4 seconds. The same duration as the breath she took 8 months ago in the consultation room when she first heard the diagnosis. Maya whispers 4 words to Arjun. The harness held. Her eyes close. Arjun climbs onto the bed and holds her. The heart rate monitor flattens into a single clean line. Outside, the storm recedes into the soft, steady rain of a Bengaluru morning. Across the city, Cyrus sits alone. He pulls a photograph of Maya at 22 from his wallet. He places it on the table. He just sits. 15 years later, a sunlit kitchen in Bengaluru. Different light, but the same room. On the refrigerator door, preserved in a clear sleeve, is a child's drawing. A mother, a daughter, a red postbox. The words, Amma, I will find you here. Anaya, now 22 and an artificial intelligence engineer, stirs tea at the counter. Her own 4-year-old daughter, Maya, sits on a stool, swinging her legs.
Anaya has not turned stage on in 6 years. She turned it off when she started college, wanting to know who she was without her mother's voice. Today, her grandmother's birthday, she has decided it is time. Little Maya points at a tablet on the counter. Amma, who is that? Anaya sits beside her daughter. She opens the tablet. Sage Boots, version 17.3, sustained for 15 years by an open-source community of children of dying parents. Their inheritance. Anaya's finger hovers above the keyboard. Her hand shakes a little before she steadies it. She types, Sage, tell me what my mother would say if she saw my daughter. The cursor blinks. Once, twice, a third time, a fourth. Over black, softly, a woman's voice begins to sing the lullaby, Tum Hi Ho Bandhu, Maya's voice, recorded 15 years ago. After 4 bars, a second voice enters in perfect harmony, Sage. The 2 voices hold the final note together for 6 seconds. Then they fade. In the lower right corner of the black frame, in small white type, for every engineer who has ever built a small, quiet system to carry a large, loud love. The last query. End.